So, yesterday, when we were going through and we were working with our trig, our main goal was to set up the trig ratios, to determine what the trig ratios were, given that you have a triangle, specifically a right triangle, or given that you have a different trig ratio. But when it comes right down to it, that's really not the purpose of trigonometry. It's not why it was created, to just get to know those ratios. Now, there is a time and a place for that, don't get me wrong, but the purpose behind trigonometry is actually doing some solving. So today, that's what we're getting into. Gonna want a calculator. Yeah, not everyone has a calculator out. Grab one.
Sorry, I was busy writing.
So, today we're going to start off with just some real basic evaluate the following. We're going to round our answers to the nearest 10,000. But before we actually get into it, let's talk about rounding real quick. How many decimal places to the nearest 10,000? Heard 3 different numbers. I heard 4, I heard 3, and I heard 7. Okay. If you do not know this already, if you are trying to figure out which place it is, look at the base word, 10,000. How many zeros are on the number 10,000? Just the zeros. 4. That's how many decimal places it is. 4 decimal places is what we're rounded to. Put the laptop away, please. To start with sine of 32 degrees. That's not a way. That's not a way.
I'm busy.
Okay, sine of 32 degrees. Any thoughts on how to evaluate this? It is not sin. Sine of 32. I guess I'm hearing some answers, but they seem to be different. Essentially, what are you getting to? What do you think that you should do? Put it into your calculator. Grab your calculator. Okay. Sine of 32. Okay. Where's trig on the TI? Good job. Where is trig on the TI? Middle. Kind of here-ish. Sine. Casio. Similar location. Okay. Sine 32. Oops. Anyone notice a problem? I got 2 different answers depending upon my calculator. Do you think that I should get different answers? Oh, your TI got the Casio answer? Did anyone Casio get the TI answer? Huh. Weird. It's almost as if there's two answers, but there's a problem going on. And there is. Okay. One of the things that you learned back in geometry, or that you worked with back in geometry, is you worked with, when you were doing trig, you were doing trig of angles, which you should. And angles were always measured in degrees. Angles have more than one unit. Degrees is one of them. It's the one that you learn in geometry. It's not actually always going to be the one that we use. In fact, we tend to do better with non-degrees once you get into higher math, because of the fact that it allows you the freedom to do trigonometry without a calculator. But that being said, right now we're doing it of degrees, which means we're using the calculator. The only thing that I have to make sure is I have to make sure my calculator's in the right units. One of these two answers that I got, the 0.5299 and the 0.5514, one of them is correct. We got to figure out which one. So you got to know how to change units on your calculator. So if you have a TI calculator, you want to change the units, you're going to go into mode. On a Casio, you want to change units, you're going to go up into the setup menu. See right here where it says setup? Do you notice it's a gold button? Which means if I want to get into it, the first thing I have to click is the shift. So shift, and then that menu button. Okay, now it gives me a lot of different options of things that I can do with the calculator. I can make it do a classic print, a math print. I could do normal answers, scientific notation answers. I can round based on what I want it to. And then there's radian and degree. The Casio, same idea, slightly different order. It goes all the way down to the bottom and you find angle. I want degree highlighted. So if it's not highlighted on your TI, scroll down. Once you get to this part, you can go left and right. Go over to degree and click enter. Mine already was highlighted, so it's not going to do anything. But you can change the units by going back and forth and clicking enter, and whichever one's highlighted is the one that it's going to be in. You want degrees. On the Casio, when I scroll down to angle, along the bottom it's going to give me deg, rad, and gra. Don't ask me what gra is, I don't know. We want deg. Now, if I exit out of that, or clear out of that, and I type in sine of 32, I get the same answer on both calculators. Okay, so rounded to the nearest 10,000. What's it look like? 0.5299. If you're going to 4 decimal places. Remember, with rounding, you look at the number of decimal places you have, you look one further. At that one further, which I guess is a little bit off from your guys' perspective. There we go. You look at the one further. You ask if that is 5 or bigger, then you round up. If it is not 5 or bigger, you do not round up. You leave it as is, 5299. Now, just as a quick note, because this tends to be one that messes with people. Let's imagine that this problem, this answer was slightly different. Instead of that 1 right there, they had a 6 right there. That means I would round up, right? How does 0.5299 round up? 0.5, and it would end up being 300 because a 9 turns into a 10. Carry the 1 and the 9 together. Really?
turns into a 10, you carry the 1, and the 1 and the 2 go to a 3.
One of the things that I've noticed is many of you wonderful with rounding. Some of y'all so we got to get better at the rounding. Some of you. Okay, perfect. And you have to assume what the rest of it says. Okay, tangent 47 degrees is our next one. And Sean, rounded to the nearest 10,000th, what do you get?
1.0724.
You got it. Okay, we're gonna do just one more like this, then we're gonna move on. Last one, secant of 40 degrees. Ethan, how do you think you're gonna do this one? Your reaction is the correct reaction. That's the reaction everyone gives. Do you see a secant button?
No.
No. There is not a secant button. There is not a cosecant button. There is not a cotangent button. You see the little ones with the -1 on it? Those are not cosecant, secant, and cotangent. Don't get ahead of yourself. That is one of the most common things that I see people try to do when they come across these. That is not how that works. What do you know about secant? It's the reciprocal of which one? Cosine. Which means, wait, how do you, I have a cosine, okay. How do I take the reciprocal of something? You flip it. How do I flip a non-fraction? Oh, I put it over 1 and then I flip it. Now I can flip it. So you're telling me that secant of 40 degrees being the reciprocal of cosine is 1 over cosine of 40 degrees. Okay, Ethan, I'm going back to you. What do we get?
1 over 0.7660.
Type it into your calculator. 1 divided by cosine of 40. 1.3054. Because you type it directly into your calculator. Yes, you're 100% right. It would have been 1 over an ugly decimal that starts with a 7. But we got to simplify, so we just type it in. Okay. So that's evaluating. Again, not our main purpose. Our main purpose is to solve. So, but in order to solve, we needed to know how to deal with trig of angles. Now, when we're solving, we're using trigonometry. What is trigonometry? It's the study of, more specific than triangles, but that's a feature of it. Right triangles, yes, but more specific. The relationship between angles and sides of a right triangle, which means trigonometry can help us find and solve for angles and sides in right triangles. So we're going to find the missing side length or angle. We're going to round sides to the nearest tenth and angles to the nearest degree. Okay, here's a triangle. Am I solving for a side or an angle here? Side. Side's got the variable on it. Okay, if you are going to use trigonometry to solve for either sides or angles, generally speaking, first thing you got to do is you got to recognize what sides you have in reference to the angle you either have or want. Notice there's two angles that I know. The 90 and the 24 degree. You never do trig of a 90 degree angle. So when you're doing SOHCAHTOA trig, which is what we're going to be doing, we're not caring about the 90. It just has to be there. Our 24 degree angle is our angle that we're referencing back to. And if that's the angle we know and we're referencing back to, first off, which side's the hypotenuse? X. Is the 11 the opposite or the adjacent? Okay, so that's my hypotenuse. That's my opposite. The adjacent doesn't have anything marked on it, which means the adjacent is not helpful to me, so I'm not even going to mark it. So I go through, I identify which sides it is that I either have or want to know. Opposite and hypotenuse in this case. Now from here, there are two trig ratios that have opposite and hypotenuse in them. Which do? Sine and its reciprocal. The reciprocal of sine is? Cosecant. The CSC one, yes. Okay. Which one's more calculator friendly? Sine or cosecant? Sine. So we should just probably use sine. In fact, when you're working with right triangles to solve, you're always going to use the SOHCAHTOA ones. That's what you did back in geometry. How do I spell SOHCAHTOA? S-O-H. C-A-H. T-O-A. SOHCAHTOA. Okay. So, we already established that sine is the one that we want, so we're going to do sine. What immediately follows trig every single time? The angle. In this case, we know the angle. Sine of 24 is equal to OH. Opposite over hypotenuse. In this case, 11 over x. And I solve. I want to get x alone. If I want to get x alone, what's the first thing I should do? You do not want to round this yet, so you don't want to plug that in yet. There's a couple different ways to do it. I could put a 1 underneath sine and I can cross multiply, or I could just get rid of the fact that I've got a fraction over there. To get rid of the fraction, I get rid of the denominator specifically. How do I undo dividing by x? Times by x. Those x's cancel. I'm left with 11. I've got x times sine of 24 is equal to 11. X is not alone. X is being multiplied by sine of 24. To undo multiply, you divide. Sine of 24 is just a number. It's an ugly decimally number, but it is a number, which means if it's being multiplied by something, you can divide by it. That's just fine. But when you are dividing by trig, you must divide by the trig with its angle. Those do not get separated, so you're dividing by sine of 24. You can't just divide by sign. So x is whatever 11 divided by sine of 24 is. That's calculator friendly. Marissa, what do you get?
27.044.
What am I rounding to? 27 or 27.0 technically. Because it says round to the nearest 10. Ta-da. There we go. Does this look familiar? A little bit. You did this in geometry. Got this triangle. Am I solving for a side or an angle? Side, which means I'm going to round to the nearest 10th. Okay. I have to determine which trig ratio I need, so I need to start identifying some sides. Caleb, x, is it the opposite, the adjacent, or the hypotenuse? You got it. Olivia, Mose, what about the 12? You got it. Hudson, which trig ratio uses the opposite and or adjacent? The TOA, so tangent. Technically, cotangent uses it as well, but it's not calculator friendly. So I'm going to use tangent. Keller. Tangent of what is equal to what? What's the rest of the equation going to look like?
Tan 15 equals x over 12.
Beautiful. I want to solve for x. Only thing that's causing the x to not be alone is it's being divided by 12. How do you undo divide by 12? Multiply by 12. In fact, if the variable is in the fraction, your first step's always going to be multiply by that denominator. Whatever it is. 12 times tangent of 15 is equal to x. X is alone. Do not multiply the 12 and the 15. They do not multiply together. The 15 is stuck inside of tangent. At this point, you just type it into your calculator as written. Harmony, what do you get?
3.214.
We're rounding to the nearest tenth, so 3 point.
That's 100. Just one decimal.
3.2. By the way, did you notice that I gave you units over here? You should probably put units back on this. Can we put the phone away, please? Nah. I've only got like 50 examples left. Okay, it's fewer than 50.
I charge my calculator at lunchtime.
Yes. Try this one out on your own. What'd you get?
Looks like right or
25.5. Okay. Now here's the thing. So far, the only thing we've solved for is sides. Angles, slightly different situation going on. But then we have lunch, and then we come back, and there's plenty of time left. Okay. So, when you're solving for an angle, you start things off the same way. You start by looking at, based on the angle you want to know now, which sides do we have? Najma, the 6, is it the opposite, the adjacent, or the hypotenuse? Emily, what about the 10? What was that? Hypotenuse. Spencer, if it's opposite and hypotenuse, which trig ratio should I use? Sine. So I'm going to use sine. Sine of what? X equals 6 over 10 or 10 over 6? 6 over 10. How do we get the x alone? No. You cannot divide. Divide is one of the most common things that people do. But you cannot divide by sine. The only way you can divide by trigonometry is if you're moving the angle with it. Do we want to move the x? No, we want the x to stay there. We want the sine to go away. We need sine's opposite operation. It's not called that, but yes. It's inverse trig. Inverse trig is the sign with what looks like a -1 exponent. Do you notice on your calculator that little -1? That's inverse trigonometry. It's trig's opposite operation. So if I want to get rid of sine, I take sine inverse. And if you do something to one side, you do it to the other side of the equation too. Now, note, this is a take the sine inverse. This is not a multiply by sine inverse. This is not a I put it over to the side. No. It is an operation that you do to things. It has to go in front of what you're doing it to. Just like square roots have a specific location, squares have a specific location, inverse trig goes in front of what it's being done to. Now, since these are opposite operations, what are they going to do? Cancel. I'm left with x is equal to whatever sine inverse of 6/10 is. Sine inverse. Now, if you've got a TI, it's going to open up a set of parentheses for you. If you have a Casio, it will not. If you do not put parentheses around the 6/10, it's going to try to do it of just the 6. So make sure you get the parentheses. What am I rounding to? It's an angle, so it's the nearest degree. What's the nearest degree to this? 37. Nearest degree, in other words, nearest whole number. solving for an angle here. What's the name of that angle? What's that thing called? Theta. So we're going to solve for theta. Aubrey. There you are. Can you identify one of the sides for me? 10's the opposite. Set. Can you identify another side for me? 40 is the hypotenuse. That means this one must be the adjacent. If I have an opposite, adjacent, and hypotenuse, which trig ratio should I use? Whichever one's the easiest. Which one is probably the one you want to avoid? Adjacent. So we're going to do opposite and hypotenuse. Opposite and hypotenuse is going to give us, well, sine again. Sine of theta equals opposite divided by hypotenuse. To get rid of sine, when you're trying to get at the angle, inverse trig. In this case, inverse sine. If it was cosine, we do inverse cosine. If it was tangent, we would do inverse tangent. Theta is whatever sine inverse of 10/40 is. Xavier, what do you get? 14 degrees. Okay. A couple of other little things that you're going to see pop up, but otherwise, for the most part, we're doing the same things, is sometimes you might see problems like this. Where it's also asking you to solve. The only difference here is I'm already giving you the trig ratio. How do you get at theta when the problem looks like that? Inverse trig. In this case, inverse tangent. Cancel, cancel. Theta is equal to whatever tangent inverse of 15/23 is. Andrew, what do we get? 33 degrees. So sometimes they might do that. Other times they're going to give you word problems. When it comes to the word problems, you do need to know a couple of vocabulary terms that are going to help you set up your triangles. They are angle of elevation and angle of depression. An angle of elevation is an angle made of a horizontal ray, technically, and a ray going upwards from it. Looks something like that. Horizontal, upwards. Angle of depression. Is made of a horizontal ray as well. And the ray going downwards. Key thing with angles of elevation and depression is they are always made with a horizontal line. Far too often, people mark the wrong angle as the angle of elevation or the angle of depression because they don't pay attention to the horizontal piece. So You have to be careful of that. I've got one final example, and then we are done with notes. A 15-foot ladder makes a 30-degree angle of elevation with the building. How far up the building does the ladder sit? Generally speaking, when it comes to these problems, you're going to want to draw yourself a picture just to get the general idea of what it's looking like. What I know is I've got a ladder, I've got a building. Okay. Start with the biggest object. Building. If I put a ladder against a building, do you generally put it straight up and down? Or do you put it at an angle? Put it at an angle. Hence, angle of elevation. It's at an angle. Okay, there's my ladder. Do you see a triangle? Yeah. Is it a right triangle? Assuming the building goes straight up and down. The only time the building is not going straight up and down is if I tell you it is the Leaning Tower of Pisa. We know 15, we know 30. Where does the 15 go? It's the length of the hypotenuse, because that's what the ladder is. Where does the 30 go? It's an angle. Here or here? No. It is an angle of elevation, meaning it goes from horizontal upwards. Which of these is going horizontal upwards? This one. I know it sounds like it should be the other one because it talks about making the angle with the building. But the way that it makes the angle is by leaning the ladder against the building, but the actual angle of elevation is still on the ground. Okay, what am I trying to solve for? The side, which side? The vertical or the horizontal one? The vertical one. I'm looking for this. Specifically stopping there, if that wasn't obvious. From here, you're doing the exact same thing as what you've been doing on all of them. If it helps you to pull the triangle away from the picture so that you're not looking at all of the extra things that you drew in, go for it. If it doesn't help you, you don't have to do it. That's the opposite. That's the hypotenuse. We are going to work with sine again. When the variable's in the fraction, you're always multiplying by the denominator. In this case, that it gets x alone. And 15 sine of 30 degrees is 7.5. Specifically, feet. Okay, we're back on page 795. Day 2. Numbers. 11, 12, 21 through 27. 39 through 36, 40 through 42.